Okay, ladies and gentlemen, greetings. We're into week 6. Next week is the final week that you will be concentrating on your project. But wanted to go, what do we want to cover in week 6? Now, we're not going to get in a whole lot of deep dive on this, but we're talking about various containers, various algorithms, various data structures. And what is being described here is kind of that next level. This is probably more of if you continued on and from a graduate, point of view, wanted some advanced topics to talk into. What this falls into. So these are going to be more of a definition, okay, of possibilities that are out there that support basically what we've already covered. But we're not going to be doing a deep dive into how each one processes. So it's more of a notification that this is what's out there, okay? And then from that, we could say, okay, yeah, I remember that there was an advanced concept that we could use on that. So it's kind of an overview for that. Let me bring this up just a little bit. Okay. So our learning outcomes, explain amortized analysis and its purpose. We're going to at least understand what that definition is. Analyze amortized time complexity using common methods. We'll go over some of those methods and what they produce. Implement advanced tree structures. Okay, we would go through the steps of what that implementation involves, but we probably will not go in detail of actually implementing. Use advanced arrays and techniques effectively. Why would we want to use advanced arrays and techniques? Understand heaps and priority queue application. Okay, we did a lot of that. We're just going to kind of touch on what are the advanced concepts to that and apply those structures to solve practical problems. The other way of looking at it, okay, understand average costs over a sequence of operations, balance trees, ABL and other self-adjusting trees. What does that mean? What does it bias? Advanced arrays, dynamic arrays, gap arrays, and we're talking about the types of arrays, heaps and priority queues. What's the advanced concepts associated with that? We've gone over that in class. So, kind of looking at that next level. Performance analysis, evaluate and compare efficiency advanced structures, and then write clean, efficient, and reusable code. So a lot of stuff here. Okay, we're going to be touching the tip of the iceberg, at least for you to know what's involved in each one of these. But again, we won't be doing the deep dive. Okay, the amortization analysis, here are various methods we can measure how well our algorithms are performing. We have the aggregate method, the accounting method, the potential method. We'll be kind of reviewing those at least as a comparison of what one does over the other. So, advanced structures, we'll be talking about advanced trees, advanced arrays, advanced heaps, advanced priority queues, everything on the advanced level. Vocabulary definition and amortized analysis is an analysis technique that evaluates the average cost per operation over a sequence of operations. Okay, so of all this code that you're writing for this particular algorithm, how do I analyze it to say, what is it going to cost me? Okay, so that's what this being explained here. An ABL tree, a self-balancing binary tree, where the height difference between subtrees is at most 1. Okay, a special type of tree. Dynamic array, an array that realizes or grows and shrinks automatically as elements are added and removed. So rather than having to take an array and redoing it and increasing it and reloading it, these type of arrays does that automatically for us. Heap, a complete binary tree that satisfies the heap properly, both the minimum and maximum. And ADT, where each element has a priority and elements are removed in priority order. Again, advanced concepts of things that we've already covered. Why this matters? Okay, scale applications use it, improve performance, handle large data sets, opinions, resource use, and special support official critical systems. Okay, so these advanced concepts that we're going to be reviewing all support these types of applications. Okay. Everyday examples, credit card payments spread over time. That's amortized analysis, advanced trees, file systems organize millions of files, advanced arrays, dynamic resizing in applications, heap and NPQ, CPU tasks, scheduling with priorities, and performance analysis, optimizing systems. Again, these are advanced systems that use advanced concepts. This is the same for these particular advanced concepts. Where are some of the common uses that we're going to be able to see? Okay. Will you be doing that in this class? No, but if they happen to be an advanced algorithms and data structure class, we might come back and touch it again. So at least you will be aware that you've heard of these particular advanced concepts before and where they apply. Again, in C++, what does that code look like? You know, an EggVL, you know, it's self-balancing tree. Here's the code, dynamic array. Here's an example of that. Minimum heap, insert. Here's how we do the insertion. Priority queue using STL. Standard template library. Okay. Here's how we would do that. So here's just again examples of what the C++ code looks like. Again, am I expecting you to be able to write code to this level? No. Am I expecting you to know what a particular line is doing? Yes. Okay. So this is why we basically have that display of the coding that is available for these types of structures that we'll be talking about in the advance. Walkthrough. Okay, this is a walkthrough with a heap insert for a heap sort. Okay, or adding something to a heap. Again, that's necessary to sort itself, but adding to a heap, what happens at each step. Okay, to kind of give an overview of just this one process. Okay, common student mistakes, ignoring amortized costs, looking only at the worst case time leads to the wrong conclusions. Okay, you got to look at the overall process. Incorrect tree balancing, forgetting rotations in AVL trees causes imbalance. Okay. Here we'll be talking again, the basics for that process we will know. And just kind of looking again is when we're processing this tree, what do we need to make sure that it's happening or not happening? Off by one errors, common in arrays, heaps, index calculations, not using the library wisely. I mean, just using the library just so you can do something quick and not looking at the library to say you need to do something right. Okay. So this is basically that particular overview for student mistakes. Again, just next week we're going to be concentrating on the project. We won't have any pop quiz, but here are the questions I still would like for you to kind of investigate. What is amortized analysis and why is it useful? How do AVL trees maintain balance? What is the difference between a heap and a priority queue? When would you use a mini heap versus a max heap? And how does dynamic array improve over static array? Okay, some of the questions I want you to dive into, be aware of them, put them in your back pocket. So in the future, in future classes, especially advanced classes, you'll have this there ready to go. Okay, so that's it for week 6. We are going to I'll be sending out information on what you'll be doing for week 7 as far as concentrating on your project. And in fact, you probably should already have that by the time of this particular recording, because I'm going to give that information to you early. So again, you should have that by the time you're viewing this. But be sure I'll be seeing other BU sometime, but on Thursday we'll come in and we'll go over this information as well as kind of go over the project and see what's going to be deliverable for week 7, the final week. Thank you, everyone. We'll see you on Thursday.